Okay, we're going to get started. Today is all about JavaScript. So this is lecture number 8, and I started it last time, but I'm going to start fresh from the beginning because we had such a weird class last week. So this week we are starting fresh. So what I'm going to go over is the concept of scripting and using scripts with HTML code and CSS. Doesn't really have anything to do with CSS. CSS is for the styling. The scripting is for the dynamic behavior. So in order to get your HTML code to come alive and do stuff, and you click on a button when you do anything, you sort of need a scripting language to make that work. And the reason why we're looking at this is that, and it's not a full JavaScript course, by the way, but we're looking at this because we need to add some functionality. We only get the screen mockup. So you need to, and JavaScript is probably one of the most popular scripting languages that's used with HTML. It is popular because it is client-side. It doesn't require any server support. It should work from your browser on your computer. You don't even have to load it to a website. In fact, all of the projects for this course, you do not have to load to a live website. You can just double-click on the files on your desktop, and they'll go ahead and open up, and you can use them. And there are a lot of things in there, as we've seen in the first assignment, to get the time, the date, the last modified version, I don't know, the browser, check the browser to see what browser it is. And an interesting question actually came up a few minutes ago before the class started was, what if my page doesn't work in Internet Explorer? What if it doesn't work in Chrome? Or what if it doesn't work in Firefox? Well, an interesting problem is that it's not going to work in all browsers equally. So what you can do is sort of test with JavaScript at the beginning of your HTML page when it first loads, test to see which browser you're using, and then modify the code accordingly. How are you going to modify the code? Well, you're probably going to use JavaScript functions, and then if it's Internet Explorer, run this function. If it's not, if it's Chrome, run this function. If it's Safari, run this one. And then you also have differences also between Mac and PC and other environments as well. And mobile phones, it's going to look different. So usually people jump on one bandwagon, and right now it's mobile. So if it works with mobile Safari and Safari, you're in good shape. And so then people that with Internet Explorer are sort of left behind with that, because Internet Explorer is not very compatible with Safari, and especially with HTML5 and some of the other things that are coming up. We've got a lot of differences among all these different browsers. Anyway, so JavaScript can help you solve that problem to the most extent. You don't have to do that for the for the sites that you're writing in this course. You don't have to do anything like that, but just know that that's available in terms of an option. So what I'm going to look at today is the client-side functionality, what JavaScript is, data types, expressions, control statements, functions, libraries, strings, arrays, and all sorts of different things. This is sort of the introductory lecture, by the way, that gives you the connection with HTML. The next lecture, which is going to be lecture 9, is JavaScript. 136 slides of pure JavaScript. And so by the end of that lecture, you probably should be able to write some simple stuff without any programming background. So it's not really a programming language, it's a scripting language. So, alright, so as I mentioned before, it is a client-side programming environment. The browser itself is what's installed, has the plugin to read the JavaScript. In fact, it's not even a plugin these days. In the old days, it used to be a plugin. Now it's just incorporated into every browser. So almost 99.9% of every browser reads JavaScript, unless you're on a strange system, with something that's not compatible. It's not Java, by the way, so you don't have to worry about Java support. You'll never see a little prompt that comes up and says, "Hey, you have to install Java." No, nothing like that. So programs are written in separate programming languages. The JavaScript, JScript, and VBScript are versions of JavaScript. VBScript is the Visual Basic version of it, Microsoft version of it. JScript is the Microsoft, well, actually it's not even that popular anymore, but VBScript is still out there. But they're just different variations. And so what you're looking at the bottom of the screen here is the script type is equal to, and remember, in the header section of the page, we can specify that we're going to use a scripting language, and so the script type here is going to be equal to JavaScript. And we have an opening and a closing. So we're using HTML to incorporate the script. And we can write the script inside of the HTML file, or we can write it outside of the HTML file and include the JS file, which you don't actually have to call it JS, but it's the text file that you're putting the Java code into. Same concept as CSS. We can do it in line. We can write the function. Actually, we can write the function in line. Not so popular, though. because you're looking at a huge HTML document, and then way down at the bottom we have a break in between, and look, there's a function definition. And it's like, whoa, where'd that come from? And then it's available, but it's only here, so everything above it didn't know about it, and it's just not very standard to see it that way. Instead, you'll see if it's only one or two functions, you'll see it defined in the header section at the top of the document. If it's more than a one or two, put it in an outside file, load the file in. That's what you're going to do, because otherwise you have to repeat that over and over again every time you create a new web page. You have to rewrite all those functions. A lot easier to put it in an outside file. Same thing with the CSS, actually. Okay, so here we have our a few definitions here. So here we have the Microsoft version of JavaScript is the JScript. The Visual Basic version, which is also the Microsoft version, is the VB script. If you're interested in looking at the history of what's going on here, they both started, actually all of them really started around 1995. JavaScript was first, however, and then Microsoft came in second. But Microsoft's always tried to have a Java kind of thing, especially with Microsoft Java. Suing for, rights over it, and they lost that. So it's like Microsoft doesn't belong in the Java world, really. But Visual Basic is pretty good. So I know most people would criticize me for what I just said, but I think Microsoft's good at certain things. Not JavaScript. VB script. You're writing on a Microsoft server. You have to use VB script, essentially. Common scripting tasks. So adding dynamic features, this is why we're going to use it. We want to add dynamic features to our web page, which means we want the web page to do something when we click on buttons, or actually it doesn't even have to be that way. That's event-driven behavior. It can be something, we can write JavaScript that takes an image and puts it across, or follows the mouse, or does something that the user doesn't initiate, that the web page is actually initiating. That's a good way of describing some dynamic features that are not associated with it. Commonly, however, we're looking at forms. Mostly we're using JavaScript with forms or with functionality. We can also use it to validate a form data. In fact, there's a ton of validation, and this is where it comes in handy. So you know about HTML, you know about CSS. If you know about JavaScript, then you can take third-party JavaScript libraries that do form checking. Include the file, because you're familiar with the content. You don't have to know anything about programming or anything about JavaScript. You just put the script in there, say, hey, this is going to be using JavaScript, and use this file, and then all of a sudden you can form check. What does that mean? Well, making sure that you have a first name and not numbers in the first name field, and all of the boxes are filled in, and then you can have this like already written library of functionality that you can incorporate into your website without having to reinvent the wheel. That's where Java got its popularity. JavaScript got its popularity. Ton of those utilities out there, which is really nice because it takes your work away, gives you a lot of functionality that doesn't exist in a regular old HTML environment. Image rollovers, another kind of thing. You can use JavaScript to change an image when the mouse rolls over something. You can actually move an image, change an image, have some dynamic behavior occur. Time-sensitive and random page elements. Have you ever seen those little timers that show up on the top, especially if you're using a shopping cart or something and you've locked in some pricing, and it says, okay, you have 5 minutes to complete your transaction, and you have this little stopwatch, the pressure's on, that's JavaScript. But anything that doesn't really need to be done on a server, that's done on a client. And the reason why it's done on a client is because you have more power than the server. Why send and receive data back and forth, especially for a timer or for a form checker, when it can be done on the client? What you can't use JavaScript for, connections to databases. Not such a good idea. Heavy-duty calculations. Not such a good idea. There's rounding errors. You can't use it for money. So you're going to use something on the server. It's going to be a little bit more accurate. It's going to be a little bit more reliable. Because then you can play, anything that's on the client is susceptible to client interaction. That's susceptible to client environment. That's unsecure. And you're giving it to the client. So you don't want to give like a formula to the client, or calculation to the client, so especially if it's a proprietary thing, something that does a password or something, not on the client. So it doesn't do everything. Some things belong on a server. Handling cookies, good, because clients are on cookies are on clients, but cookies aren't really something we use anymore. Cookies, by definition, if you're not familiar, because everyone says don't use them, turn them off and delete them. They're just little text files that get sent from the server to the client that sit on the client's computer. And you can use JavaScript to open up those little cookies and see what's going on, you know, read some information. It was meant essentially to make the page last past the connection, so you could store information on the client. So when the client went back to a particular website, it would load the cookie information, and then everything would appear as if you never left the website. So, and you can't check cookies from a server, you can only check it from a client. So what happened is people wrote programs using JavaScript actually that opened up cookies of any type, not their cookies, and then read the information. So then people said, well, that's not very secure. It's not, but you don't put things like social security number, a name and address in a cookie. But how do you trust others not to do that? So the problem with cookies is that you don't know what the developer is going to put in the cookie file. And whatever you type in on the computer is essentially, could possibly be in a cookie. And who doesn't check their account balances or I don't know, pay their bills or something online these days. So how do you know that stuff's not being stored in a cookie file? You don't. So you want to remove cookie files actually, because you don't know what's in them. So, or don't put in social security numbers and account numbers and personal information into web forms. Well, okay, don't use the internet if that's the case. That's what people are using it for. You also have cookies on mobile phones too, by the way. Same concept exists, actually. The mobile environment is the same as the desktop environment in terms of the web browsing behavior. All right, and the alternative to the cookie is the session data. So if you take it off the client and you put it on the server, it turns into session information. And then the session information can be cached. And so when the client comes back in, it's loading it from the server. Nobody else can get to it but the server. So it's kind of more secure that way. So defining programs with web interfaces, utilizing buttons, text boxes, which we're going to talk about today, clicking images, prompts, and frames. And then we have the limitations of the client-side scripting. Since it's embedded, it's viewable to the world, so you don't put passwords in there. And they're not fully featured. So scripting languages are not full programming languages. So JavaScript and any other scripting language is going to fall short of giving you 100% full programming capabilities. And if that's the case, then you pick up Java and you write applets. Now, applet's not such a good idea either, because an applet is a compiled program that is run in the browser, and you get a browser plugin for it. But the applet code is downloaded. It takes too long. It's like every time you're going to run a website, you're going to download a program, and then you're going to run the program from your computer. Takes way too long. So what ends up, and then it clutters up your computer, and then you've got cache directory of like, I don't know, 10 gigabytes of crap from the last. So people clear that stuff out. So no one's using applets anymore. So the alternative to that is you take the Java EE course and you write servlets. So it's the same thing with the cookies and the sessions. Excuse me. You take the applet, you put it on the server, now it's called a servlet. So, or Java Bean or something where it's now running on the server, but it's really a small little program that maybe in the past could have been done in the form of an applet, but it's more secure on the server, it's managed by the server, and we have only one instance of that that's running instead of it downloading to everybody, and then everybody's running it from their own computer. Just one copy of it's running from a server. So you can kind of control it a little bit better as well. And then you can integrate it with other Java technologies. So we're not going to look at applets in this course. We're not going to look at Java EE in this course either, but that's where those technologies sort of fit into the big picture in terms of what I'm talking about in terms of JavaScript. All right, so let's talk about JavaScript. So we have what's called the document object model. That actually came out of Internet Explorer from years ago, and this is what we're using in terms of that one of the assignments actually had you doing this, and it was in the back of one of the lectures that I gave you for the time and the date and stuff, where we can ask the document when was it created, or we can ask the document and we can get things from the document. We can also put things on the document, and JavaScript is object-oriented. So we have a hierarchy through the DOM, which is the document object model, of a window, and then a document inside of the window, and then elements that are inside of the window that are inside of the document that are inside of the... So it's a hierarchy, and in one of my lectures coming up, I'm going to have the hierarchy outlined for you. Model's different for different browsers, so it's pretty standardized though these days, although it is changing and it's going away. So it's kind of like one of the trends is not to use it. However, it's still around and people still do use it. So it's just like everyone hasn't moved over to HTML5 yet. I mean, HTML4 is pretty popular. People are still using that. They're not using 5. 5's got its downfalls. Not fully supported on all browsers. And not reliable. Well, to some. For some things. So, anyway, back to JavaScript. Here, the output of a JavaScript code is displayed as it directly entered into HTML. Okay, so document.write. So what you're looking at here, let me zoom in so you can kind of see what I'm talking about. Here, document.write is what I'm focusing on in terms of a command. This displays text on the page because the page element is the document. So you can get from document, you can get an input box. You can get a text field to get input and see, we'll get the text from those. What is the text? Or you could write text to those elements. Or you can write it just to the flat document. So the sort of the hello world of JavaScript just uses a write. In this particular case, the document write code here says document.write hello world. So it just prints something out on the page. Why do you want to do that? Well, I don't know, because you want to use JavaScript, you don't want to use HTML. You probably could have done that in HTML. And you can actually inside of the document. So document.write, and we're using HTML tags inside of it to format it, because HTML just does the formatting. We don't actually have to do it this way. This is just an example to let you know inside of JavaScript this is how you get something. Because what ends up happening is you're going to have a calculation and you're going to want to put it on the screen. So what are you going to do? Instead of passing the information all over the place and storing it in a cookie file and doing all this other stuff with it, just put it on the screen. So the document.write allows you to do that without having to flip right inside of JavaScript, without having to go and end the script and take the data and use the data somewhere else. So it integrates the functionality. So text is displayed, and it also includes the HTML tags. As in C++ or Java statements, you put each one of the ending lines here has a semicolon. So this is the proper statement here, and this is actually called a method. So you don't have to know anything about object orientation. But this is an object, the document, and the dot is what they call dot notation, and this is a method called write. And the method is taking on a parameter, hello world. So once you get familiar with the syntax, if you're not a programmer, some of you are, but some of you are brand new to this field. Once you get familiar with this, all the method calls are going to be the same on all the objects. So you're trying to figure out, well, what's the object, and then what's the method call. And so you get those reference books, or you go online and you say, how do I write something? How do I read something? And then you can pretty much figure out. And then we have comments in here. If you are a programmer, you can appreciate this. It's the same as C or C++ or Java. The two slashes here gives us on the same line, the comment is recognized. If we go to the next line, we have to put two slashes on the next line too. Instead, we can use this notation here with the opening and closing, and then we put anything inside multiple lines. I prefer this because I just put in small comments. And comments are nice because, you know, this is a silly code to demonstrate output, but you know, it might mean something else. It might mean this is the final amount that the customer needs to pay us or something, or this is the sales tax or something. You know, it might make a little bit more sense. Alright, so we have data types and variables. Just like in programming languages, we can have variables. We don't have variables in HTML, but now we can have variables. So JavaScript only has 3 primitive data types. As I was mentioning before, not a full programming language. It's stripped down, made just for web design. Strings, numbers, and booleans. So most of what you're going to do is a string, because the customer is going to be typing stuff in, or you're going to be pulling text. So text is string. It's followed by opening and closing, so it's enclosed inside of opening and closing quotation marks. Numbers are just numbers, and numbers fall into floats, doubles. There's a bug. Okay, there we go. All sorts of different types of numbers all fall into the number category. And then booleans, which are true and false. Booleans are nice because then we can use them for flow control. We can say, if the customer put this in here, if it's true, then do something else. And then we can check to see if something is true or false, which tells us, you know, oh, don't let them go to the next page because they haven't filled out their address or something. And then we can, you know, check that. And again, just as I was doing last time, you can cut and paste these examples and put them into text files and run them. I'm going to save you that and let you guys do it as your own exercise. But here we have message is equal to howdy, pi is equal to 3.14, yada yada. And so in here we have x is equal to 1024, document right, and then we can actually put x in here. And so when we do that, the pluses here are concatenating. So we have concatenation, we have addition, subtraction, we have all sorts of different things. It's dynamically determined by the data type. So if it's a number, the plus is going to add it together. If it's a string type, it's automatically, no conversion required, it's automatically going to concatenate it, which means, you know, put the string with the other string and print it out to the screen. And what else we got going on here? Here's a number, but we're putting it here with a string, so it's going to come out as a string. This is also going to come out as a string because it is a string. So x is equal to a string. So both of them are going to be treated the same way. So variables names are case sensitive, which means a capital X and a lowercase x are two separate variables. You don't have to declare variables. They will be created the first time you use them. So if you're familiar with programming techniques and you go, oh, x, integer x, string x, you don't have to do any of that. There's no variable declarations. You just go x is equal to something or other. So it's kind of sloppy programming, but it's not meant for programmers. It's meant for scripters. And variables are loosely typed and can be assigned different types of values. So we can say x is equal to 1, and then further down, x is equal to hello world. Works just fine. No error messages at all. And you'll find that the case with most scripting languages. In fact, if you want to take this a step further after this course, PHP, Python, or Perl would be your next choices of scripting languages. They're server-side. So JavaScript is probably the only client side, well, okay, one of a few only client sides that are running right now. If you want to do something on a server, you're going to pick up PHP, probably, which is not a bad language. Very similar to JavaScript. The same concept actually applies. The same document.write applies. The same rules apply, which makes it a lot easier to pick up new scripting languages, I should say. So don't be afraid to experiment with languages because they're all very similar in terms of the concept, and all you need to really do is pick it up, start practicing with it, start writing some code, and then you go, oh yeah, dynamic assignment, I don't have to go x, integer x, or I don't have to declare a data type. What you get, however, with PHP is you get more data types. It's a little bit more robust, but they're all dynamic, and you can mix and match, and you can do the same things with it. So we have operators and expressions, and so what do we have here? We have, as I mentioned before, we have concatenation, we have numeric operators, we have rationals, equals to, not equals to, greater than, less than, logical, this and this, or that can be applied. So as in C++ and Java, precedence rules apply. They apply to expressions, so it's the same as math in terms of the precedence rules, so multiplication, division. So operators are left associated, so they're evaluated from a left to a right order. Same thing you get in basic math concepts. And must be careful when mixing strings and numbers. So we get, as I was mentioning before, a number plus a number is addition. A string plus a string is concatenation. A string plus a number is, convert the number to a string, then concatenate. So by default, everything's a string. If it's a number, you have to add it to another number. Otherwise, it's a string, which can be kind of, so that's why you see people making zeros, you know, they have these fake variables in here that stand for an empty string, or it's a zero or something. So when they add it in, gets calculated correctly. So kind of prevents mistakes. So here's an example here with all of the different examples that I just kind of went through over here in terms of the different combinations that exist. So we have control statements. As I was mentioning before, they're almost identically the same as C++ and Java and C, if you're familiar with any of those languages. If you're not, then here's your information. The conditional execution, looping, and then we have counter-controlled looping. If Boolean test, well, that would be if x is equal to hello world. So whatever you put into here has to come out to a Boolean expression. So it's going to be evaluated to true or false. So if true, do some statements, or if false, depending upon what you're going to do. If not true, it actually executes by default on true. So if this doesn't evaluate to true, nothing's going to happen. So if Boolean test, some statements, else some statements. And then we have opening and closing brackets. If you're brand new to programming, it just says this is the code we want to execute for the if. This is the code here we're going to execute for the else. So it kind of gives us the if-else kind of sequence that we're looking for. In terms of our conditional looping, it's called conditional because we're putting a test in there for a while. So while true. And then when while turns into false, we're done. And the loop stops. Which means inside of here in the statements we have to put something in there that's going to change this to false. Otherwise the loop's going to go on forever. We have websites that have loops that go on forever. It's not a problem if that's the design of the website. Gaming websites. You know, we have a little tic-tac-toe game out there. Actually, you can really create a nice tic-tac-toe game with JavaScript. And there's a couple of them out there, actually, where all the functionality is controlled by JavaScript, and it just loops. It just continuously loops, and then clears the board and comes back up again. Put it inside of a while loop. While there's a turn, do something, and then change the turns. Or counter-driven, it's going to be very similar. In fact, this is identical to C or C++. So in the counter-driven, we say for, and then we have this is going to evaluate to true or false. And it's going to be an initialization, which is going to be integer I is equal to 0, followed by a semicolon. I is less than 1. I plus plus. That's going to say, you know, when I is less, well, that's actually not going to work past one iteration, but get my point. As it increments with each for execution, it does the test. If it's true, it keeps going. If it's false, it stops. So, all right. So here we have an example. It's a puzzle. So suppose you took a piece of a paper and you folded it in half, then in half again, and so on. How many folds before the thickness of the paper reaches from the Earth to the Sun? That's a lot of folds. So here we have in our example here in which we're going to figure out the thickness. So the distance to the sun is equal to this. The thickness of the paper is going to be equal to this. Fold count is 0. While the thickness is less than the distance to the sun, thickness is going to be times equal to, which means double it because you fold it, fold it, fold it. And the fold count plus plus, so you can count up how many folds. And then at the end when this is done, and it's going to be done because of the while thickness, which started out here, is less than the distance to the sun, it's going to go on forever. It's a long distance. Then after you're done, and the number of folds is going to be equal to fold count. You actually run this and you'll get the fold count. So whether or not you're going to actually do that, I seriously doubt. I just want to fold it and maybe make the paper a little bit thicker. Maybe like, you know, a third of the distance from the Earth to the sun. You only have like 1 or 2 folds. So here's our math routines. So we have a predefined object that contains routines and constants in it. And as I was talking about before in terms of the object called document, we have an object here called math. It's a library that's built into JavaScript. So we can go math.square root, math.power, math.maximum, minimum, floor, and ceiling, and we can actually calculate out this, and these are methods that we're running, by the way, on the object. One of the things you're going to notice with JavaScript, and this is the standard with practically every single programming language out there, the names of the objects are capitalized. So that, because we're case sensitive, we have to make sure we actually use a capital M if we're going to use this object. Capital D for document. Capital, so If you just remember, all objects are capitalized, which is kind of the standard you're supposed to use in other languages. This is strictly enforced. Other object-oriented languages don't require you to use this. But it's one of the sources of confusion because you put the method in there and you write this out here, but you use a lowercase m and then it doesn't work. And the browser doesn't come back and say, JavaScript is case sensitive. Please capitalize the M in math. They're not going to tell you that. So instead you're going to be playing around with it for weeks and months until you finally figure out, why is it not working? And you cut and paste it from somewhere else and it works. And why is that working? It's because it's capitalized. Also special characters, not going to do you any good either. So line return characters, when you cut and paste something, it's going to cause you problems as well. So here we have math.power, math.floor, math.square root, and we're just using it in here. And how do we know we're going to use that one? Well, we've got in here JavaScript. It's built in. So it's a built-in function. Predefined math object contains routines. Question, what does this program do? I don't know. You figure it out. Cut and paste it. Put it in your web browser. You'll figure it out. Alright, so here's random page elements. Math.random. Well, if you're doing the guessing game, this comes in handy when you're trying to create functionality. So math.random returns a pseudo-random number in the range from 0 to something, depending upon the range that you give it. So you can alter the range using other math routines, useful for generating dynamic page elements. So here's our function, and our function here, and this is a good example actually, it's a random rolling of dice. So we have 2 dice, and we're going to roll the dice. Craps. You guys heard of craps? Or dice. You roll the dice and see what's on the dice. Go pair of 2s, pair of 3s. So let's see. Don't learn dice if you don't know dice. Right, so function, random integer. And we have a low and a high. And we're going to return the math.floor random integer low here. Low plus a high. Looks like we're going to do here. We're going to return, this one is going to return a random number that's going to come out that's going to be an integer value. So down here we have roll 1 with random integer 1. Well, probably could have fixed this actually. The low is 1, the high is 6. So it's going to give us a number between 1 and 6 that's going to come out of there. Probably could have just put that in here instead of sending it as parameters, but then it wouldn't show you how to send parameters to a function. So this is the function here. Probably should put it in red because I'm not sure if we've seen a function yet. And the function name is called random integer. When we call the function, which is we're calling down here, we're going to say roll 1. This is a variable that we've declared. This is the body section where we're using it. This is the head section where we've defined the function. If we don't want to put it here, we put it in a file and we import the file. Or we load the file in at the beginning, just like the CSS. And I have an example of that coming up. When we run the function here, we're assigning this value, the return value. Most functions will have a return. So when you do this, roll 1 is equal to random integer, send it parameters 1, 6. It'll come back and return a number between 1 and 6 that's going to be randomly generated using the random function with the seed and the with the starting and the ending point, I should say, in terms of this concept. This doesn't have to return anything. This could just print something to the screen. But in this particular case, it's returning something. So this is referred to as the function call because we're calling it with parameters, or we're calling it without parameters, doesn't really matter. It's called a function call. And then the return is the value we get from the functionality that's going to exist. And we assign the return to a variable in this particular case. So one is going to have the same they're the same function that's being run, but because this is going to randomly generate a number, we're looking at the built-in method from math.random that's already given to us.
So it's running 2 times and having 2 different answers in it?
Yeah, it's going to run once here, and it's going to run once here. So each time it runs, it comes back with one number between 1 and 6, and we have 2 dice. So we have dice number 1 and dice number 2, or roll number 1. It could be the same dice, roll number 1 and roll number 2. And so we're going to get 2 separate numbers that are going to come out of this. And we're going to write the numbers to the screen. What is this going to do? The roll plus again. Well, okay, so in here it's going to say, roll 1 plus, a picture. basically we're writing the numbers out to the screen in this example. These GIFs don't exist. So if you run this code, actually, I don't believe this example is up there anymore. I had them running in a different course that I was teaching, actually. So this, you can probably just take all this stuff out here and not put the image. It's just going to put an image up, and it's going to say, well, a picture of a dice. It's going to say this is 3, 2, 1, kind of. But you can possibly see how, hopefully you can see how the function works in this particular example, and how the function call is being used, and then the return value is being assigned to these variables, and then the variables are just being written to the screen. So you'll use document write a lot, actually, to put something out. And document write in this particular case is putting images out as well as the values of role 1 and role 2. So it's doing a lot of dynamic behavior there. Interactive pages using prompts. We've seen this actually. Enter your name, put the name into a prompt. And that's a JavaScript actually. So what do we have here? We have a prompt that says username is going to be equal to a prompt. Well, the text that comes out of the prompt from here is going to be assigned to username. So somewhat crude interaction with users can be placed in the prompt function. The prompt is supported by every web browser. It's not a pop-up window. It's a prompt. So it's still being supported. Unfortunately, what ends up happening is it can be kind of irritating, especially if you're on like a mobile phone or something and this prompt is taking up the entire screen and you can't get past the prompt. So you want to make sure that the prompt has a, has a purpose if you're going to use it. Plus, a lot of people don't like prompts because they look like pop-up screens. And plus, where are you going to see the prompt? So usually it's minimized in terms of its use. You don't want to have an entire application that works in the form of prompts, because then you have all constantly stuff popping up for the user to enter in. And what ends up happening is the screen behind the prompt gets frozen and the browser won't react until the prompt is. And if you don't see the prompt on the screen, it's lost somewhere, hidden under another screen. It could cause confusion. So
Prompts are generally used to get only one input, right?
yeah, one piece of information and minimize it.
But if second assignment is asked to get 3 times,
Correct.
it goes at the same time.
Yep. In fact, the interesting thing is the assignments is do what I say, not what I do, or what's that expression? I'm having you do stuff like the use of frames. I'm having you do stuff that you're probably not going to do in practice, which is why I'm telling you, you're probably not going to use that technique. The one that you're going to have to do, in fact, actually, you could do that. For the prompt assignment that is asking you to get in all those GPAs, you can put them all in one line, separate them by commas, and then use a split to split them out. Or you can go enter grade number 1, enter grade number 2, enter grade number 3, enter grade number 4. The alternative to that is to put up a form and put a text box, which is what you're going to do in the next assignment. But your first assignment is not using forms. So one of the assignments that she was talking about has you in the assignment say put a prompt up, or here's an example of how to do it, here's a prompt, Alright, so the next version of that is the more sophisticated one, which is the one I'm recommending. So you have a form and you just fill out the form. You put all the stuff in there and then you click calculate GPA. It takes everything, adds it up, divides it by the number, and it's fixed. So you can divide it by 5 and the rest of them can be zeros or something. You don't have to be, it doesn't have to be that sophisticated. So many different ways of doing it. You'll see the form used a lot more than a prompt, is my point. The first argument of the prompt appears in the dialog box. So here's we have our prompt here, which is our first argument, is what's going to appear in the dialog box. And the second argument is the default value that will appear in the box in the case that the user enters nothing. So if nothing enters, then nothing's going to be entered. Here's the second value. So in the prompt we have 1, comma, another. So we have 2 values. One of them is going to be, what do you want to prompt to the user? In some browsers, this actually appears in the dialog of the window. In some browsers, it will actually appear in the box where it's supposed to appear. So I think Firefox puts it in the window bar, but IE will put it in the box because this was meant for IE originally. So anyway, long story short, it's the 2 components that you can put in. The function returns the value entered in by the user in the dialog box. So forms will provide a better interface for user interaction. This is that little quote on the bottom. It's basically what I was saying before. Use a form. Don't use a prompt for this. Prompting for numbers. So if you haven't noticed, this is leading into the second or third assignment. I think it's the second assignment actually, that looks at a JavaScript code for calculating GPAs. So this is one of the things you might want to do for that assignment actually, is to use a prompt. So note the prompt always returns a string. If it returns a string, you have to parse it to a float or parse it to an integer, which is kind of weird. Why does it always want to return? Everything is a string. So just think the default data type for everything is a string. And so if you remember that, then you know, oh, if it's a string, even though the user put a number in there, I'm going to have to convert it. So if the user enters the number 12 at the prompt, then the string 12 is returned. It's a string. Recall the plus applied to the string gives concatenation, as we saw before. So if the numbers are to be read using a prompt, then you must explicitly be converting them to something else like parse floats, or parse integer, or parse double. So depending upon the data type. In this particular case, we want to call them floats. So here we have a prompting for numbers. Enter the first number, number 1. Number 1 is going to be equal to. Then we took number 1 here. You can do this. Is the variable is equal to the variable? Yes. So we're taking number 1, and now it's going to be equal to a parse float number 1. And number 1 was the prompt. It says enter the first number. And we're doing the same thing with the second number. And then when we go down here, the sum of the two numbers is going to give us a number. It's not going to do concatenation, it's going to do addition. When you do that JavaScript program, you're going to run into a case in which it's going to do concatenation, unless you parse it. And it's a GPA, so you're going to parse float, because you want precision on that number. When I get all done, we'll take a look at that assignment so you'll see what I'm talking about. If you haven't looked ahead, probably should be doing it right now if you haven't done it yet. User-defined functions. Alright, so what we've done here, then, we're going to create a function that's definitions are very similar to C++ and Java. No return type for a function since variables are loosely typed, and no types for parameters since variables are loosely typed, and no the by value parameters passing only. There's no passing by. If you're not familiar with other languages, this is not going to make any sense to you. But think no data types. So we just say function instead of a data type. So here we have function is prime. And we don't have to put data types anywhere. So no data types on the parameters either. So we have comments in here, so we're assuming n is larger than 0. And returns true if n is prime, else it returns false. So we have if, and this is our function opening bracket, and down here is our function closing bracket. And inside of the function we have if n is smaller than 2, return false. If n is equal to 2, then return true. Else for, and then we have this word variable in here, which is kind of interesting. If we go with VAR, we're declaring a variable. It means it's a new variable. Because what if I existed? If we said I is equal to 2, but we have I somewhere else. So in this particular case we're saying we're declaring a variable called I. So VAR I in this particular case. So if the first use of the variable is preceded by a variable, then the variable is local to the function, which means it's a new I. Not any other I we probably have used before. Because here's what happens, you do this a lot, and people reuse, you know, I, A, B, X, common names. And then you redefine something that was like on another function somewhere else. You've now reset I to something. So when your page loads up, you got bad information being shown because I changed in value when you used it. So it's common to see variable, VAR, used here. This basically takes and creates a local scope instead of a global scope, which brings up an interesting question. The way JavaScript can be used nicely inside of a HTML page, by default, everything is global. What does that mean? When I use I in a function, if I'm not doing this way, it's I throughout the entire page. So every time I use I, I'm using the I, not a new I. So I can run a function, and then I can take that information and still load it up, and I don't have to reset anything. It's still visible, it's still global, it works everywhere inside the page. So there's no resetting, there's no copying, there's no passing of information back and forth. The information is the information, the variables are the variables. Everything shows up nice and consistently. First name is always going to be first name, last name is always going to be last name. And then on another page is I go to one name, and then I go to another page. It's still the same. It's except for the session. that's going on in your browser. So those variables never go away, which is nice. Because then you can have like, okay, welcome back, Barbara. And then down here, Barbara, and down here, Barbara, and down here, Barbara, all over the place. And it's global. You don't have to keep like copying and moving and stuff. But it causes problems, especially when you're using it inside of instances like this where you just want a temporary variable. Then you go variable here. So for modularity, it should make all variables in function calls local. So inside of a function call, if you're going to use variables, make them local. Because you're going to return a value, true or false, but you don't want to change variables. You don't want to change settings that you've done for variables. So here we have another function example, and we're going to put the function in the head. So the function definition goes in the head section, and the head is loaded first, so the body is defined before the code in the body is going to be executed. So here we have function is prime, and it's up here. So, and then down here on the bottom, we're saying if is prime test number, then do something. So we can, again, this is a function call. We're not assigning it to a variable in this case. We're just saying is prime, which basically says run is prime, and give it test number, and test number's up here. We prompted the user for the number. So you can do something like this for the GPA, actually. Write a little function, put it in the JavaScript, put it in the head section, excuse me, and then run it inside of the code. Here's another example. We have the random dice rolls revisited. So up here we have a random integer, same as before. And then we're going to run it here, and then recall that the dynamic dice page here could define a function for generating random numbers in a range when it was needed. Easy to remember and promotes reuse if we put it up here. So if we go back to the random dice number here. Let's see. What did I do with my random dice here? It was in the head section. Okay, so this example is pretty much pointing out the same concept of it, putting it into the head section. But we can take this, I believe the direction this is going in, is we can take this, cut it out of here, and put it into a file, and then load the file in, especially if we want to reuse it. So we have these things called libraries. Yes? And the head section is perfect. Yeah, I'm going to go over the assignment, actually, when I get done with this part, before we go into the next part. So we can kind of see, once you've seen this, you'll see the assignment's pretty easy. If it's not, then maybe after the next lecture, it'll become easy. Alright, so JavaScript libraries. So better still, if you define the functions that are useful for many different pages, store them in a separate file, and take the file and load it into the page when you need it. And so here's an example, and it's called random.js. This file doesn't exist, by the way. It's been moved to a different server. Inside of here we have random number, low high returns random number, here integer character, number of. So we have a lot of different randoms that we can use in this example. So note, as with the external style sheets, no tags in the JavaScript library file are being used. There's no tags, it's just the function declarations. So then you load the library using the source src attribute in the script. Nothing between the tags. So here we have, down on the bottom, we say, instead of JavaScript, in this particular case, we said script type is equal to text JavaScript. That remains the same. But underneath we say source is equal to, give me the source of the file. It's just the path, the URL to the file, and then we end the script tag. So instead of sticking it all here, we say source is equal to something. And then we have it all in a file. Same format, actually. You can just cut and paste that stuff, stick it in a file, add the source as the file that you've created. And that makes it cleaner looking. Makes it, and here it is here. So we have source is equal to the name of the file. No function in here. Some people don't like this because then they can't see the function. You gotta go out, open up this file. What is this function? How many parameters does it take? What am I supposed to call it? But what if you wanted to create several different web pages and all use the same function? It only shows up once, and you load that into every one of the pages, just like CSS, actually. So it makes it easier. So a little bit about strings. We looked about numbers. So if numbers come in as a string, and strings are string, everything's a string, then we have to convert it to a float or an integer or double or whatever we want to use with it. If we have strings, we can Search within strings, concatenate strings, do all sorts of different functionality to it. So there's string libraries that are used that are also built in, just like the math works. So a class defines a new type, formerly an abstract data type. So we can encapsulate the data, the properties, the operations, and the methods. So we can actually create our own data types or our own strings. So a string encapsulates a sequence of characters enclosed in quotes by definition. So some of the string properties, and we can, okay, so number one, we can create our own data types if we want to, but you don't have to go this far in this class. Number two, we have built-in data types. String is a built-in data type, and built-in data types have properties. One of the properties that's commonly used is length, because we're going to check the string length. If it's 0, that means the user didn't put anything in there. We're getting in the string from what? In a form, we see a text box, so we get the text out of the box. We say, what's the length of this text? 0. Oh, the user didn't put anything in here. So we go, okay, prompt the user, put something in there. We have character at is the first character, this is the second character, that, depending upon, and it returns the character at a particular index. And substrings, we can take this string, the first name and last name, and put it together if we want to create two substrings. We can find the two substrings within a string from the start and an end position. We can take that, concatenate it with that over there. So it's used a lot with concatenation for substrings. Convert it to upper, convert it to lower. Why do we want to do that? Well, because we want to send it to the database, and the database needs it in a certain format or something. Or we want to show everyone typed in all caps, so we want to convert everything to lower or something. Make it consistent. So to create the string using assign using a new. So let's take a look here as this kind of thing here. Or we can just do a direct assignment. So new is implicit, which means it's going to be put in anyway. So these are two options you have. You can say word is equal to foo. This is what we've seen so far. But as I was just saying before, JavaScript is object-oriented. If you are an object-oriented programmer, and you want to keep with that same pattern, this, believe it or not, is more logical to you. Sometimes. Word is equal to new string. Boo. Means the same thing. But some people like this syntax. So what's going to end up happening is you're going to be reading somebody's web page. Because, you know, unless you're creating a brand new website, you're never going to be writing this yourself. So instead, you're going to say, hey, can you fix this problem on this web page? Okay, no problem. You look at the web page and you look at this, don't freak out. It's the same as this. But someone wrote it like this, which is, you know, it's a new object. So properties and methods are called explicitly. So we can say word.length. Same thing as with the math.square root. Word.character at. So we can call them explicitly. So, and we can get the method implications that occur. So here's a string example. Suppose we want to test whether or not a word or phrase is a palindrome. So we have radar, Bob, and noon. So we must traverse the string, read it backwards, compare the characters from, as an example, Bob is a palindrome. If it reads left to right and right to left and it has the same meaning, then it's a palindrome. So noon is also one. Radar is not one because it's, oh, is it? And radar is one. They're all three of them are. Yeah, I quick looked at this one. I went, it can't be. But they all three of them are palindromes. So what do we got here? We want to make sure it's not case sensitive because actually that would come out wrong. So you must traverse the string comparing the strings from front to back. So it should be case sensitive, so make all letters lowercase before testing. So here's the test. So a function is palindrome with a string. So it assumes the string is a string, and it will come back and return true if the string is a palindrome, else false. So string is going to be equal to string.toUppercase, which means put the string in uppercase. You could probably just put it in lowercase too. Just doesn't really matter. Just the entire character string has to be in the same case in order for this to work. Because capital B and a lowercase b are two separate characters. Okay, so for the variable, and then again, notice we're using var I because we want this to be local. I is equal to 0. I is less than the math.floor.string length divided by 2. So I++, which means let us go from left to right, the entire string length. If the string at character I doesn't equal the string at this length minus I minus 1, which means the opposite one, so you're comparing left to right, then return false if it's not equal. If it is equal, then you're good. So B is equal to B, O is equal to, oh, it's a palindrome. Same thing here. So it means this character is equal to this character is equal to this character, and this character in the middle is equal to itself. So we can kind of come out with the nice little functionality with that. That's a nice example, depending upon whether your website users wanted you to have that or not. I don't know. Better yet, we would like to be able to test phrases. So Madam, I'm Adam. A man, a plane, a canal, Panama. So you must strip out the non-letters, and here we have a semicolon, commas, periods. Is this Madam? Anyway, I'm trying to read it now. Okay, so you must strip out the non-letters out of the phrase and then test it as before. To handle the phrase, you must be able to strip out non-letters. And what are we going to do here? Well, we're going to use another technique. So this is going to be function strip. And what do we have here? Variable copy. So we have the copy here. It's going to be local, which means it's going to be reset. So just in case we forget to set copy, it's going to be equal to this current copy that we have. Copy is going to come in. For I is equal to 0, I is less than string length I plus plus. So go through the entire string. If the string, a character I, is larger than or equal to A, it's a member of the alphabet, and the string is smaller than or equal to Z, it's in the alphabet. Copy is going to be equal to the copy at character I, which means it's going to be an alphabetical character. Inside of A through Z, we have we converted it to uppercase, so we only have uppercase characters. If we're running that uppercase first, which is what we're doing here. So it's strip string to upper. So what we're doing is we're running this function called strip, and in the function call, we're saying for the string, convert it to upper. So now we have strings between A and Z that are going to be used here, which kind of gives us a nice alphabet. Excuse me, I knew I was going to have to sneeze. That was a sneeze. Okay, so, and then we can run the is palindrome function on the result. So now we're going to say, what do we got here? Excuse me. We're going to run the function is palindrome, and in the is palindrome, we're going to run it inside of here. We have the result that's coming back from the string that we're running up here for strip. And then here we're just basically doing the same thing as we did before, but now we're not using the commas and the periods and everything else, just the characters that are included. The point of this example is to show you can run a function from a function. So inside of the function call, we're running yet another function call. So, all right, and here's another piece of code here that's going to actually run it. And these are the two functions, and this is the HTML code that's calling the functions. So here's our script that we're going to put up here, and then down here on the bottom we're going to say if palindrome text, then write it out. This gives us a cleaner web page, especially if we put this in a separate file. Then we load it up, and we're just looking at our HTML code, just as before. Arrays. Alright, so we have a Java array, so we can basically store multiple of the same type inside of the same variable name without having to have 25 different variables, all representing instance A, B, C, and D. So since JavaScript is loosely typed, elements do not have to be the same type inside of the array, which is what you don't get with other languages, which makes JavaScript actually kind of easy to use. So here's an example here. To create an array, we allocate space using the new array 10, allocate space for 10 items. Items is equal to new array. If no size, will adjust automatically. Or the items is equal to all this stuff here. So elements do not have to be of the same type inside, and then we can implement them in these three different ways. Usually you're probably going to do this. Items is going to be equal to A, B, C, D, E, F, G, separated by commas, whatever it happens to be inside of the array. So you can assign a size and the values to it automatically. If you're a Java programmer, you might like the new array. It's the same thing as new string. And actually you can go new array 10, and it's going to give you an array, and there's no type here. There's no type being specified. So it can store of any type. So to access an element in the array, just like in C or C++ or Java, we use the brackets here. So these are not the smooth, what do they call these things? Parentheses. So these are called brackets. And so I is the index value that's going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, because we start out with 0. Same problem you get with Java and C++ and traditional style languages. The index values start with 0. So the length property stores the number of the items in the array. So we can go here, items, dot length, and it's going to return the length. Items I, it's going to return item 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 to display the items. So for the GPA program, you might want to use an array if you want to. You can. We'll look at that program in a few minutes. So suppose you want to simulate the die rolls and verify an even distribution. So you can keep an array of the counters and then initialize the counter to 0, and then each time you roll an X, increment rolls X and display each one of the counters. So let's take a look here. We're going to put it in a file. We're going to use that random.js file that we had before. And remember now, this is easy because we can just include it in the header, in the head section, and then just call it down here. So the stuff in red is the new stuff. So we have the roles, number of roles to 60,000 roles. That's a lot of roles. Well, we don't have to do this manually. JavaScript's going to do this for us. Die size, there's 6 sides to the dice. And the roles are going to be equal to a new array of the die sides plus 1. Make it 7. Because we're going to go 1, 2, 3, 4, 5, 6. Because we don't want to do 0. So for I is equal to 1. So what we did was we took this array and we're not going to use a 0. We're going to start with 1. Because we're not programmers and we don't want to start with 0, which is the only reason why it's done this way. Well, unless you are a programmer, then you can start with 0, no problem. Round is equal to 1, I is less than the number of roles, length, I++, roles, I is equal to 0. So, okay, so for I is equal to 1, the roles are going to be a random number. Take a random number starting with 1 and the number of sides, which is 6, and then add it in. So for another one, we're going to have a number of I. We're going to print out. This is the number that we put in. So we're going to randomly generate all of these different roles, and we're going to stick them in the roles array, which is what we get here. So the roles array is going to keep track of all of our roles that we're going to randomly generate from each one of the 1 through 6 selections that we're going to get from the random integer that we're going to do. And the whole key is with this here, roles. And then we can print out roles. So usually we'll have to use a for loop to print it out. This is printing it out for each one that we're putting in individually. At the end we could just say a regular old for loop. For I is equal to 1, I is less than 60,000. Print out roles I plus plus, go back around, and then essentially what you're doing is you're printing out each one of the roles. You have the date class. Alright, so strings, any questions about arrays first? Arrays, in all essentially, for all intents and purposes, use the same as any other programming language. The only thing to keep track of in terms of arrays is that the fact that there are no data types. So it's more flexible. But then again, you have to convert items to strings or numbers if you're going to use them, because everything is a string. Even the same thing applies towards arrays. So, but in this particular case, we have an array of numbers that we're putting in. If we treat a number with a number, we automatically, let's say for example you wanted to keep track of GPAs, and you put them in as numbers, and you take a number and you add it to a number, you're going to get a number. There's no conversion required. If you take a string from a string prompt, you have to convert it to a number to get it to add to a number, because it's going to be a string, which is how you're going to end up with this problem actually when you start working on the assignment, because then you'll have to convert it depending upon how you're getting the information. So, alright, date class. So the string and the arrays are most commonly used in classes in JavaScript, so other special types might also exist. The date class can be used to access date and time. So to create a date object, you use the new or supply year, month, and date as desired. So here we have today is going to be equal to new date. Sets the current date. And you go, well, what is new date? Well, the current date of the system of the computer that you're working on. So if you're running this website and the user loads it up and they're on the East Coast and they're 3 hours ahead and it's midnight, they're going to get the next day. So if you want the date to be consistent, you don't put it in JavaScript on the client side, you put it on the server. So that's one of the reasons, going back to the concept of how do I know if I want to put it on the server, how do I know if I want to put it on the client? Dates are important. Purchase dates. So sometimes when you get and you fill out a shopping cart and you know today is, what is today? Wednesday? And but you're in London or something, or no, the company's in London. And you're saying, well, it's really yesterday, or is it tomorrow? Or the date's different. And the invoice says, oh, you purchased this on Thursday. I'm like, I did? I thought I did this on Wednesday. Because the server's keeping track of the date, normally for a shopping cart for purchases. Because you don't want to ship something before you pay for it. And you want to make sure you can account for all of the sequences of the transaction that's associated with it. However, if you're just creating a Hello World website, you can use the date of the client machine. And all you have to do is change the date in your Windows system, and then the date on the website changes too. Oh, no. See, I put the payment in before I took the check out. No, you didn't. So, you're not going to be able to do that with a banking application, by the way. The bank's going to have its own date and its own time stamp as well on the server. So we have new date, get year. What we're looking at here, we've got get month, get day, get hour, dot minutes. So date is time and date. It's a timestamp for the current time and date that's associated with the system, the operating system that you're working on. And so the get year, get month are methods that you can run on the date to get the particular information that you're familiar with in terms of what it is you want to get. Here's our date example. Now is equal to new date. Document.write now. Put it to the screen. Time is equal to AM. Hours is equal to now.getHours. Hours is larger than 12. 12's equal to, well, minus equals 12. Make it equal to 12. Reverse it. Time is now equal to PM. So if the hours is larger than 12, change the AM to PM. So now we have AM to PM. And if the hours is equal to 0, then the hours is equal to 12. The day starts out at midnight, actually. Which is kind of weird. I think the day should start at noon. Why should the new day start at midnight? Because you're like 7 or 8 hours into the day by the time you can even get up in the morning, right? So, anyway, just a little bit of philosophy to think about. So by default, the date will be displayed in the full, as an example here, Sunday, February 3rd, GMT. Actually, the standard format is going to give you the time zone as well, specific time zone. It's reading it from the operating system, so that the information might actually vary depending upon what platform you're on. So you could pull out portions of it, AM, PM, and print it out differently, which is what you're going to do. Otherwise, you're going to get some funny looking date. So here's another example here where we can add and subtract dates and the result of the number of dates in milliseconds. So when you go on there and they're too lazy, so they're going to put it in your JavaScript code on the client and say, hey, your invoice is 30 days late. Or you're 15 days late. How did you get that? Well, here's how we calculated it. We said date is equal, now is equal to new date. That's today. The year is equal to the new date, some year that we're going to set. Seconds, day, hours, minutes, seconds, blah, 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 blah. We can do some subtractions here. So we could say seconds is going to be the days times this, and the hours times that. So we can convert, we can find out the differences between two dates or two times, and the differences that might reflect some sort of information that went right to the screen. So, and the example, you'll see what happens there. So we have the document object. Both Internet Explorer and Netscape. Okay, take the word Netscape out and replace it with Firefox. We don't have Netscape. Well, we do have Netscape. Netscape is still around. Not so popular though. Still works on Unix actually. But put Firefox in here, because that's the predecessor. Allows you to access information about the HTML document using the document object. It's not a class. It's part of the document object model, as I was mentioning before. So document.write, document.url. So that's the property that gives you the document of the HTML document, the location of the HTML document. It's the URL that the document's located at. Why do you want that? Well, because you want to know where it came from. What site are you on? Why is that? Because when you call up customer service and you say, "Hey, can you look at the bottom of the form there? What does that URL say?" You can read it. Oh, you're off the old site. Go to the new site. Here's the URL address, and so you can troubleshoot problems with where are you getting this document from, perhaps. Or you can use it to save it in a cookie file, so you always go back to the same location or something. And then document last modified is going to be a property that gives you the date and the time of the HTML document that was saved, which is what you're going to use. I believe you're going to use one or two of these in one of the assignments, actually, probably the first one or the second one. But we'll see. So let's see, we got document.write, document.url, document.lastModified, which is going to give us that information. And basically it's the same concept as before, but we're using a script type, JavaScript, document.write, document.lastModified. So document.write is JavaScript, document.lastModified is the object model. So we're using DOM with JavaScript, which is kind of interesting. This isn't really JavaScript. This is the object, the document object of the model. So it's there whether or not we use JavaScript or not, which is why you don't have to use JavaScript for one of the assignments actually to get the last modified date. It's going to give it to you automatically. We also have this thing called the navigator object. Navigator.appName. Remember before in the beginning of the lecture I said it's nice to know which browser the user is using, because then you can modify the content of the web page to meet the needs of the browser, and this is how you're going to do it, by using the navigator. So the property that gives the browser name. So navigator.appVersion is going to be the property that gives the browser version. Also, you're using Internet Explorer 6. When we're going to have you run this function instead of that function, because the prompt's not going to work, or because this is not going to work. So here's a dynamic style sheet example that's going to pull out if the navigator.appName is equal to Netscape or Firefox or document.write. Look at this, document.write. Put in the link for the style sheet that's going to be netscape.css. Else the document.write put in. So in the header head section, we're actually dynamically writing to the document the CSS include line that doesn't exist until we actually write it. We're going to get one of this or we're going to get one of this, depending upon what browser we're using. And we're testing it by navigator.appName and not the version, just the name. So then we can pick a style sheet that's going to look best in the browser. Because one style sheet does not meet all browser interfaces. Not so compatible. You'd think by now it would be, but it's not. So you can do this with anything. With JavaScript functions, with include files. You can totally customize the interface for Internet Explorer versus Chrome versus Firefox, and it'll pick out. And if you're curious, well, what does it look like? Just print it to the screen. So write a little thing here that says document.write, and then inside of there go navigator.appName. And at the top of the screen, just put it in a blank piece of paper, put it in a blank HTML screen. On the top it'll say Firefox, Chrome, Internet Explorer. It'll say what it is, which is kind of interesting. So, and then you can use it to modify the content depending upon. And then here's two examples here. We have MSIE.css and Netscape.css, the two, and we're just changing it around a little bit so it looks different. So unfortunately, people do this all over the place. Well, you have to. When I use the word unfortunately because it's kind of a hassle. Think about all the mobile browsers we have now too. So if you want to make a mobile version of your website, just test for the mobile browser. Mobile browser comes up, and then you can automatically change the entire look and feel of your website to meet for mobile displays. So this is probably the most important thing I'm telling you today in terms of JavaScript, because this is a JavaScript code, believe it or not. It's just a matter of taking and running an if-else, which makes it JavaScript. You have to use JavaScript for this. which is why I'm teaching you JavaScript in this class, although it's HTML and CSS. You can't do anything without some functionality, without some dynamic capabilities. This you're going to do because nobody makes one website anymore. You make one that's going to appear on mobile phones. So you're in a mobile app, you're in a mobile browser, you want it to look like a mobile, you want to have, and we'll talk about design for a few minutes, big buttons, not so much text, not so much graphic. You want it to look a certain way. Well, you create a style sheet for that. In fact, a style sheet can utilize components that are optimized for the mobile interface. You put this on your website, user loads it up. Doesn't matter what they're using to load it up with. They're going to get the customized view, the customized CSS for whatever it is you want to do for each one of the platforms. Hassle. A lot of work, but it actually makes for some pretty interesting websites. We actually have one on the ITU website. If you bring it up in a mobile browser window, it knows it's a mobile, and it brings up the mobile version. And then we have one for, actually the one's the same, which is what they probably should do, especially for the EMS. Change it, because if you have not noticed, it looks different in Firefox versus Internet Explorer. Some of the stuff actually scrolls off the screen in Internet Explorer. It doesn't fit correctly. So if they had, okay, so ITU people, if you had done something like this, you can change the CSS actually, or even change the format of the screen using scripting like this to modify the look and feel, essentially modify the HTML stuff and the CSS stuff to adapt to the different environments. So anyway, enough on that one. User-defined classes. So lo and behold, we have the ability to define our own classes. So those our own classes are our own objects. So we have functions that we're running, which is probably what you're going to do most of the time. You can also create your own classes. You can define new classes, but the notation is awkward. So you simply define a function that serves as a constructor, and you specify the data fields and the methods using this. You do not have to do this for this class. So if you're concerned with, oh, you don't understand JavaScript already, tune me out, think about something else, surf the internet, because you don't need to do this. You don't have to create any classes for this class. So there's no data hiding. You don't protect data or methods. Objects are interesting because, JavaScript is interesting because it's an object-oriented programming language. And every object-oriented programming language allows you to create new objects. So this is how you're going to create a new object if you're going to do it. So what do we got here? Define die function, i.e. the constructor. And then initialize the data fields in the function. Proceed with this. So we have this. And similarly, you can assign methods to the separate define function, which uses this to access. So if you've written a class before in another language like Java, you would say class die sides, and then in here you'd have data members and member functions. The same kind of concept. But inside of this here, this is die.js. So this is our class definition. We have two separate functions. One function is defining the data members. The separate function is defining the methods that are part of it. And one of the methods is role. So if we made an instance of die, we can go .role. We're just running the methods that are inside of die in terms of the functionality. And what is that going to do? If we have to use this, because then this creates the variables or the data members that are associated with the object. So this .number size is .roles. This .role is equal to role. Role, here we go, here's role. So this is the connection between the role function, the method, and the role. And the die object. So this .role, number of roles plus plus. When we roll it, we're going to increase the number of roles, and then we're going to return, the number that's going to come out from the role. So if we see this here on our class example, we have now new die. New die, it's like new string or new something. It's a new object now that we're creating, or new dates, as we saw before. It's really just that object that we created, and we created it up. We're loading it in. Source is equal to die.js. So here we've taken the code that we put in, it's just a matter of creating functions and using this inside of the functions. We include this in, and then down here we say die 6 is equal to new die 6, die 8 is equal to new die 8. We're now using this as an object. So down here we can say die 6 dot roll. So instead of using it as a function call, we're using the JavaScript as an object. We're making an instance of the object, and we're running methods on the objects. You probably aren't going to do this until you take a JavaScript course or until you start practicing it, but you probably could do it anyway. This is pretty simple, actually. You can do it from this explanation alone, probably. But what's going to end up happening is you're going to look at other people's code and you're going to go, what is that? Well, it's a method call on an object, and the object was created by the programmer or by the web developer. It's not a built-in object, but it's working the same way as a built-in object. So if you know object-oriented programming and you're familiar with it in other languages, this is simple. This is extremely simple compared to having to create an instance, having to create a class definition and go through all of the, the class and compiling the class and then making, it's the same concept, but you're doing it with functions. So this is a function, this is a function, and you're using the word function in here. It's a makeshift way of creating an object using functions. Or you can simply just use functions and call the functions. Depends on the style of programming that you like. So here we create a die object using the new, similar to string and array. New array, new string. This is why people like the new, because they get familiar with that and they go, oh yeah, new array, new string, new die, new date. And it's kind of consistent instead of just saying date is equal to, now is equal to date. Okay, you can actually do the same thing. Now is equal to die. But does it look like object orientation? This kind of tells you, oh, it's a new die, it's a new object. So depends on your preferences with that. Each die object has its own properties, number of sides and number of rows. The document toDie initializes the number size, so the argument here, we're sending the argument in here, so the constructor is going to run and initialize the size. And then the roll method, so it's called on a particular die, accesses the number of sides that are updated for each individual instance. So die 6 roll and die 8 roll are going to run roll on the separate instances of those objects that were created. And they're all of data type die. So don't be concerned if you don't understand objects or object orientation. You don't have to do that for this class. So what do you have to do for this class? I just want to briefly kind of go over the assignments right now. Because we're approaching the midpoint. I'm going to have the midterm, if it's not available yet, I'm going to have it available soon. But I just want to kind of do a touch base here to make sure we're all on the same page in terms of what's been due or what should be due soon, because you don't want to wait till the very last week of the class to turn something in. And probably starting next week, I'm going to start grading stuff, because I don't want to wait till the very end of the course either, because you guys sit and you wait till the end of the course and you go, oh my god, I failed the course, or oh my god, I passed the class. You want to know kind of like how you're doing as you're doing it. But I actually went in there the other day and I noticed there's not that much stuff submitted. So today, I'm going to remind you that we have stuff to submit. So we have this one here. Some people have actually done this one already. And note your page should use standard HTML features, be viewable in either Internet Explorer or Netscape. Okay, so take the Netscape out and put Firefox in there. Or Chrome, or Safari, or whatever you want. The note I wanted to make on this one is anything. It can be used in any website, in any browser. If it only works in one browser, see if you could put a little note in there somehow. When you submit the assignment, does it allow you to put text in there? I don't know. Just say, works only in IE, works only in Chrome, if you want to make sure that I can see it properly. Or you could probably just put it on the top of your website if you want to. If it's an HTML, just say, hey, well, it only works in Chrome. Just something to give me a red flag. Say, hey, it only works, or then I know which one to load it in. So I've gone over this assignment in the past. You're just going to basically create a little website, a little web page. You're creating a single web page. In the second assignment, you're actually creating a website. It's using frames, I believe. Nope. It's not that one. Which is the one then? If I have this correct? Page should be divided into 2 frames. Okay, the first one is using the frames. It's a simple web page with the frames. The second assignment is the one I wanted to go over today. Let me make this a little bit bigger so you can see what I'm talking about. We have more on JavaScript, by the way, that we're going to do next Wednesday as well. Today's just the start, but I sort of want to preview this for you so you can sort of see what I'm talking about. Create a web page, and you're going to call the web page gpa.html. And you can compute your grade point average given the grades and the hours of courses completed. So the page should repeatedly prompt the user for course information regarding the course name and the grades received. And the program should contain a prompt for reading in the grades until the user has entered empty, left it empty. So now we can test for emptiness. We can, test for prompt. This is bad practice, but go ahead and do it this way. You can, if you want, because you can use a split. I'm going to talk about split actually on Wednesday, but you can probably figure it out on your own. You can take the string and delimit it by the commas. So you can say, enter in all your grades followed by a comma. You can fix it for one class if you want. So I'll assume to be Math 245. And you're just going to put in all your grades. So you can put in A, B, C, D, E. If you want, you can design it so it puts in 1, 2, 3 numbers. You can put in numbers. You can put in characters. You can put the whole thing in one line, one prompt if you want, separated by commas. Or you can say, okay, enter first one, enter second one, enter third one, enter fourth one. You can fix it so that they can only enter 5 grades. Enter first grade, second grade, third grade, fourth, fifth. Stop! I'm sorry, no more grades. You can totally customize this to meet whatever parameters you need in order to make this work. The concept is not on your JavaScript skills. The concept is, can you incorporate the script inside of an HTML page and use it? You can put it in an external file. You can put it inside. You can create the function inside. You're going to need to create 1 or 2 functions, no objects required, to run the functionality. What are you going to do? So once the course grades have been stored, just use a prompt. If you don't want to use a prompt, you can be more sophisticated. And you can use a form. A little bit harder. Because as we've seen, we can say value 1, VAR 1, or what, just make up a name, grade 1, is equal to prompt, enter grade. Next line. Number 2, you can do it individually if you want. Or you could put them in an array if you want. You know about arrays a little bit. It allows you to experiment with them. And then if you put them into array, you can take this prompt string and use split with a delimiter of a comma and split out each one of them and stick them into the array if you want. That's a little bit harder, a little bit more advanced, but it depends on your comfort level. Once you put the grades in, you're going to have to compute a grade point average. So once the course grades have been posted, you have the overall GPA. The grade point average are computed as follows. The grade points, aka quality points, are assigned for each one of the grades. So if the person puts in an A, that's a 4 point. A B plus is a 3.5. So you can do, if you had the user put in characters, you have to convert the characters to points. If you had them put in points, which you're more than welcome to do if you want, then there's no conversion. Otherwise, this is going to give you practice putting together. If the string is an A, then you have if this, then if then for all of the different ones that you have, and then you're adding them to more variables. It's practice using variables is what this is about. Here's an example. For example, suppose the student entered in the following course information with each line. So they got a B plus 3, 4, C plus is 3. Anyway, you can make up the scale. Oh, that's the course units, three unit course. Okay, you don't even have to keep track of that. Mimic this. This is a wide open, and I'm open to flexibility in terms of how you want to do it. Implement the overall concept. How's that? This is the number of units. Great. So it was a B plus and it's 3 units. Oh, so it's for the total grades for all the semester, for the semester points. So These are 3-unit courses math. 245 is a 40-unit course. Is that what this is? Anyway, so the total number of grade point earned for the student is this times 3, that times 4, that times 3, divided out. You can do it per class, per semester. You can do it one semester. You can do it one class. You can do it for the entire academic career. You can choose the options that you want for this. But the theme is grade point. If your comfort level is not so good with JavaScript, it's the first time you've ever done anything like this at all, take one class, enter in a fixed number of grades for that class, and then calculate out the grade point average, the grade in the class. So it makes it easier. Divide this total by 16, okay. So your page should display, so this is your display. Your page should display the number of grade points, the number of hours, and the GPA, as well as the course information in a readable format. You can use a document write for this, and you can document write it out. It can look like this, or it can look different depending upon how you're doing it. If it's for one class, then it's going to say math something. Assignment number 1, assignment number 2, assignment number 3, assignment number 4, midterm exam, whoop, final grade. And your grade point, your final grade, you're going to have the total grade points, you're going to have the total number of hours, and your GPA is going to be for that class, if you're going to do it that way. And you're not going to keep track of the total number of hours. If you're going to do it this way, then you're going to keep track of it by course, by grade in the class, by the units per the course. You're going to do it that way. So I don't care how you do the calculation, is what I'm saying. So feel free to have a little bit of freedom in terms of that. On the bottom, I've got the split for you. So for processing the information for each course, if you do it in this format here, this is one class, you got an A, it was worth 4 units. So you've got the class name, the grade, the number of units. If you do it this way, the hint that I'm giving you on the bottom is you want to use the split method. So you should utilize the string method split, which splits a string into an array of substrings for you automatically. For example, line.split, and we're putting in here this line here, will return an array of strings of line using a white space. This is the white space as a delimiter. So you put this is the delimiter in here, and you're splitting it by the delimiter, so you can put a comma in there, or in this particular case, it is a white space. There's a single white space in between each one of these. So if you have the user put it in with commas, separate all your grades out by commas. You can do it that way. You can use white space. Each one of these prompts is going to be for a class. So the course name, the grade, and the credit hours. And then you're going to click OK. And then the next one's going to be another course. If you're going to do it this way, this one actually might be easier to follow it this way, because then it gets more complicated because then you have to think outside of the box to figure out how you're going to calculate it out differently. So this might be an easy way of doing it. So if you split it, split actually will save yourself a lot of time and energy because it'll automatically create it for you. In the next, any questions on that assignment, by the way? In the next assignment, number 3, we're going to do another version of that. So let's make this zoom in a little bit here. So you should be hopefully working on assignment number 2 and have a number 1 done already. We'll be on number 2. And then I would do part 2 and number 3 next. Part 2 and number 3 is the same thing. But you're going to create an event-driven version of the GPA program. And it's going to be a single text area for inputting the information for all courses. So now we're going to practice best practices. Get rid of the prompts. And we're going to put a form in. And I haven't talked about the connection between that yet, which is the theme for next week, actually. Is where we're going to work on this version of it. So what do we got here? We're going to input the information for all courses inside of a form or text area. So we're going to have a text area here. You don't have to use a text area, by the way. This text area is going to parse this as a string and take the string, same thing you did with the split. If you want, you can have boxes, text boxes, and just put in here and fix it. Say, here, put 5 of them in here. 1, 2, 3, 4, 5, and then click it. The text area is a little bit more complicated because now you're working with an entire string and you have to split the string out. But you can split it out, no problem. But it's doing string manipulation. This is a GUI item. When you click on compute, you're going to run a JavaScript function, and JavaScript function is going to do the same thing as you previously did in the first assignment. So here's my tidbit of information here. So in the first assignment, if you only calculated it out for one course, do this one that way. You're following through with the same thing. Same thing you're writing for the first for number 2, the first version of this program. You're just going to take that and you're going to convert it into a GUI version of it. Using, instead of the prompt, you're going to have a text area, or you're going to have text boxes with labels into a form, and you're going to do a form processing of the same information reusing the same code. You can use the same formula, the same function. You're just changing the GUI. So this is actually kind of easy if you use the first one as a pattern. You just write part 2 of this. Turn them in separately, however. I want to see the first version and I want to see the second version. The second version gets zipped with the second part of this one for the third assignment. So, as before, you should have the name, grade, credit hours. Each one of them is going to be on a single line, and the user clicks a button and it's going to essentially process the information for you and make sure that the output is correct. So when you press the button, it's going to put the output down here. It's going to fill this in. So this is pretty much what the GUI looks like. And it's just a GUI version using a form instead of prompts. So any form you want, actually. The second part, or I should say the first part of the third assignment, which is a brand new one. It's not. This one's actually pretty easy if you reuse what you have, and you can reuse what you have. In this one here, I'm giving you the code, the JavaScript code. So, 1995, we had this thing. This guy invented this national holiday called Talk Like a Parrot Day, and it's in September. Actually, it's passed already, where people need to talk like a parrot. So this website is going to enable you to talk like a parrot. So you put in a regular sentence like, "Hello, how are you?" and it translates it into parrot talk. So you have 2 text boxes, or 2 text areas. One where you write the English regular normal words, and you press a button and it puts the Talk Like a Parrot translation into the second box. Not too hard, but it's giving you practice using JavaScript and functions on forms again. So this one is all about forms in JavaScript, because we really haven't looked at forms in terms of your practice. So you're going to design and implement a better web page for translating the English text into Talk Like a Parrot. You're going to use JavaScript code for performing the translation. It's provided to you below. I'm giving you the JavaScript code. You may use this in your program. So the phrases are arrays that contain English words and phrases with pirate translations to them, and the array is used by the translate function. And takes a string as input, searches the string for substrings from phrases, and replaces the English phrases with the pirate translations. So your web page should include a text area, which the user enters in the text, a button or a clickable image to initiate the translation, and any other text, and in another text area where the translated text is going to appear. I'm sure you've seen this before in some websites where you've got enter something in here and it, press a button, translate it. It translates it to French or Spanish or something. Well, that's what you're doing, but you're going from English to Talk Like a Parrot. And let's see, add images, embellishments, or anything on the page, expanding it. You can also expand the vocabulary if you want. You don't have to. But here's our phrases. Hello is ahoy. Hi is yo ho ho. You know, these are the translations. Down here's the functions. This is a variable declaration, by the way. The function capitalize, which is going to capitalize things. Translate with the text. And so you're running translate. Translate's going to work with this. So you need all of this code to work together. Cut and paste it. Make it work first. Test it out. And then make the GUI work with it. So when you press the button, it's going to run the function. It's actually not too bad. It looks harder than it is. You can also add lib to the code, add anything you want to the code. But it's not a programming assignment, it's take the pieces and put them together to make them work using HTML. In terms of CSS, I don't care what you do with it. You don't have to use CSS at all with either the GPA, both versions, or this one. No CSS requirement. So let's see what's next. We only have 5 of these things total, right? 5? Yeah. The next one, well, considering that this is not too bad. The next one is about combining all 3 of them together. So let me give you some pointers on this one. Because you seriously do, because the holidays are coming up, you seriously do want to start working on this stuff. It's like almost, it's already October. Well, as soon as Halloween hits, we're going to have Thanksgiving, and boing, we're done with the class. So it's going to be over with before you know it. So the CSS, HTML, and JavaScript programming. You're going to write an active password checker. Uh-oh. So this one, you're actually writing the code yourself. In the GPA, it's kind of looking, that lecture that I just went over is going to give you everything you need to know for that one. In the Pirate, you're using code that's already given to you. This one, you're writing your own code. So it's a little step up, and it's the last one that you'll have to actually do this with. So you can write what's called an active password checker using a CSS, and HTML, and JavaScript. Purpose of the active password checker is to prevent the user from selecting a password or password phrases that are easily guessed. Again, you're taking a piece of information that's coming in through a form. It's going to say, enter your password. And you're going to check the password, and you're going to come back and say, it's a good password, it's a bad password. So it's not so hard. But it's actually something that's done a lot with form checking. So this may be done by comparing potential passwords with a dictionary. You can do that technique if you want. Or examine the mixture of characters selected, clicking user information, and so on. You know, if you want to make it more elaborate, you can. You know, put in your first name, put in your last name. I'm sorry, your password cannot contain your first or your last name. If you want to do that. You can make it as elaborate or as simple as you want. Your active password checker must make sure that the selected password is at least 8 characters in length. Use a dictionary of bad passwords. You know, like foul words and stuff, or things you don't want. So you can make up foul words, you know, like bad, ugly, crazy, stupid. I don't know. So that the password excludes matches that are bad words. For words in the bad word dictionary, you can construct your own dictionary as long as it contains at least 10 entries, 10 bad words. So bad passwords are passwords that are easily guessed as well. For example, 1, 2, 3, 4, 5, 6, 7, 8. Test, help. Actually, the word oh, here it is. The word password should be in there too. How many people try password? You know what I really like is when people put Gmail. There's a guy who has the name Gmail. Is the Gmail name? How do you remember your email address? It's Gmail. Like, how does that happen? Like, Gmail never should have allowed him to have Gmail. And then there's like one person who's got Yahoo at yahoo.com. Alright, so you may use any implementation techniques that you want. Feel free to experiment with JavaScript and other features of programming techniques. Anything you want. Your own design, your own password checker. Anything you want on the form, or anything you want on the page as well. Last but not least, create a website. Do anything you want with it. Your own design. But it has to have more than one page. So, using the techniques that you've learned in this course, create your own website project. This is kind of like the capstone kind of project that you're going to be working on here, of your own theme. Each page in your website should use a single CSS and theme, which means it should use an external, but it should be the same single CSS theme for the entire website, which I probably should have worded differently, because it seems like from this wording each page has to have its own CSS. No, that's why I'm going over this. One for the entire site, because you want to practice best standards here. So you want to have one. There should be at least 5 different pages within the website navigation menus. You want to create the navigational system so you can navigate. You should have a site map, you know, so that you have a home button, you have a page 1, page 2, page 3, and everything takes you back to, and all the pages have a home on it, which is referred to as a map, site map. You can use any images, scripts, themes that you want. Feel free to be creative, follow website development best practices, and make your website look professional as possible. So this is your opportunity to make it look as professional, as commercial, as professional. Do not use any professional tools, however. You're still doing this in Notepad. And your website should be developed using a text editor, not a website generator tool. Use HTML, CSS, and any other technologies that you wish to code with by hand. Do not use a what you see is what you get website development tool. I can't tell you how many times students have turned stuff in from website development tools. Don't do that. So what this assignment is going to have you do is going to have you put the pieces together and assemble something that you're hopefully going to be proud of in terms of this is my best website I can create at the end of this course. Showing the best work that you can possibly put together with HTML, CSS. You may use JavaScript, you may use any scripting language that you're familiar with, but you don't have to make it scripting. You don't have to use JavaScript for this. Just use CSS and HTML and follow a common theme and have at least 5 pages. How this is going to work is you're going to put it into a directory. Unless you're going to upload it to a website, you're going to need to put it into a common directory on your hard drive. If you put it into separate files, all files must be located in the same directory. If you stick it inside of a folder, even if it's on your desktop, all the files are going to find each other just fine, and you can run it from your local system just like everything else. And then just zip up the folder and send it to me. And then that's how you submit this one, yes?
You can use the first assignment instead of waiting for the fifth one.
You can if you want to. You can take the first one and turn it into the 5th one if you want. You can reuse your own work. That's acceptable. You can't reuse somebody else's work, but you can reuse your own work. No problem. Alright, I just want to revisit the website just to make sure. I thought there was one more, but I guess not. We're almost done, don't worry. Let's see, I have to catch up from last week. We didn't do any of this stuff last week. So let's see. We have, those are the 5 assignments. Okay, so I don't have, let me just take a look at the syllabus real quick. It's kind of like, it feels like almost the halfway point in the course. I sort of like want to touch base on a few things. Oops, I have the syllabus right here. And the syllabus. We have a midterm exam. And we have the CSLO. And do I have the midterm exam out there? I don't believe I do. Is there a link for it? It is not available yet. So I need to make that available. And there's also a CSLO essay which is available, I believe. Yes. And the CSLO essay, which you can probably also be working on, is, oops, close this one, is a written paper, and the written paper should be 2 to 3 pages in length. Must include at least 3 reference citations. And it has to include research that you're doing. It has to be written by yourself, not cut and pasted from the internet. As a general guideline, and I've discovered some international students don't understand the concept of plagiarism, as noticed in the previous term. If you cut and paste, you may only do it for 1 to 3 sentences, no more than 3 sentences in a row. And if you do that, you have to put quotation marks around the 1 to 3 sentences and provide a reference citation for where that came from. You can't take Wikipedia as an example and cut 4 or 5 paragraphs from that and paste it into your assignment. And the ironic thing is some students actually include the Wikipedia link at the bottom. It's like, well, this is where it came from. I'm like, but that doesn't make it so that it's okay just because you put the link in there. In fact, it doesn't really matter if you put the link in there or not, because turnitin.com is going to find it for you. So be cautious. For those of you who would like to graduate, who are working on the last term and are going to run into the situation which we had with the last term, it was manually checked last term. This term is going to automatically be checked by the EMS. So when you upload your CSLO essay, and this is the one that they're going to catch it on, it will automatically go through turnitin.com, and it's going to be red flagged, and you're going to be saying that 90% of this paper comes from Wikipedia, or 55% of this paper comes from... I don't know what the threshold is right now, but I know it's going to be over 50%, which means if you cut and paste and you put in 1 to 3 sentences and you provide a reference citation, that's okay. If you are copying and it's less than 50% of something, I don't know if it's 50 or 40%, I'm not quite sure on the statistics of this yet, because this is the first time we're doing it, then it's going to be red flagged. When it's red flagged, it automatically receives a 0. This is 25% of your grade. You don't want a 0 for this. So what I'm saying is, it doesn't really matter how crappy it is, write it yourself. It's your opportunity to practice your own writing. So we're going to have the whole system automated, so I have no idea what the automation is going to do to you, personally, but if you can check it yourself, which is actually something that you can do. So here's the other thing. So students are allowed to check it themselves, so you turn it in before you turn it in through the system to make sure you're going to get a green flag out of that. Because if you get a red flag out of it, you're not going to get any points for it. So I believe that they're in the process of putting together the student accounts and the student logins, and I don't have that information yet. So somebody here remind me, maybe my TA can remind me, that towards the end of the course I need the information for, I need to tell the class how to check it before they turn it in. On your other assignments, you can feel free to send it to me, and I can look at it by email, and I can say, hey, this website's good. No, this is not good. And most of this stuff is going to be unique anyway for this class, so I don't really think we're going to have a problem. But I can kind of foresee problems with the CSLO if you're not aware of what's going on, which is why I'm mentioning this. Okay, past the plagiarism issues. On to the assignments. What are you doing? You're writing a paper. The paper is going to be on one of these topics, not all of them. So you pick one of the topics explaining how HTML differs from XHTML and XML. Or perhaps you want to talk about W3Cs, or you want to explain why you want to use a forms in a web page design. Tables more effective. Maybe the differences between static and dynamic web content. That may be an example. Or maybe selecting a topic from this area of scripting that is a topic of your own choice. None of the above. Make up your own topic. Write a paper that is on material related to this class. So if you wanted to keep it within HTML, CSS, or JavaScript, don't give me a recycled JavaScript paper either, because what they're doing is they're building a database and it'll find recycled papers as well. Actually, the other thing that Turnitin does is it finds matches among students. So you can't turn in the same thing somebody else has turned in, because even though it didn't come from the internet, it came from another source that was in the same database. So it takes all of the submissions and compares them against themselves as well. So it's actually pretty cool. It does it automatically too, which is weird. So somehow they've integrated that into the EMS, but I haven't seen the results of it yet. So I guess we're going to be the guinea pigs for the term to see what happens. So we'll see what happens. I hope it works. Yeah, no, it should work. If not, definitely there'll be someone manually checking it anyway. I believe I have to manually check it, so we'll see what happens. Not on your own work, no. And I've heard horror stories, actually, of people who have multiply submitted, and it comes back. Yeah. Oh, that's a different problem. That's totally different. All right, any questions on the CSLO? My advice is, yes? The very last day of the course, which I believe is December 1st or something. Hold on a second, let me check the LMS for that date. I will check this for you right now. I believe I set it to first week in December, but let's see. Assignments. December 14th is the last due date for everything. Everything is set for December 14th. And I can see I only have 4 people who submitted the first assignment and 1 person who submitted the second. That's why I'm like, okay, I need to mention this stuff because you don't want to wait until December 13th to do all this stuff. Okay, we're done for today. Unless you have questions. Make sure to sign the attendance. Attendance is going around right now.